As reported by the South China Morning Post, the facility is expected to sit some 6,000 feet below the ocean surface and be completed by 2030 with the ability to accommodate up to 6 scientists who will inhabit the deep-sea space station for up to a month at a time. China has released the first details of an ambitious new plan to develop a deep-sea research facility with the potential to transform marine exploration, which will be situated some 6,000 feet below the surface of the South China Sea. As reported by the South China Morning Post this week, the facility is expected to be completed by 2030 with the ability to accommodate up to 6 scientists at a time who will inhabit the deep-sea space station for up to a month at a time. After years of debate and technical reviews, China has given the green light to a deep-sea research facility that could redefine marine exploration, while amplifying Beijing's geopolitical leverage in one of the world's most resource-rich areas. The Cold Seep Ecosystem Research Facility will be anchored 2,000 meters, 6,560 feet, below the surface of the strategically significant South China Sea, which is also subject to a number of competing territorial claims. The facility, one of the deepest and most technologically complex underwater installations ever attempted, is scheduled to be operational by around 2030, with room for 6 scientists on missions that will last as long as a month. The planned facility, which is known among the research community as a deep-sea space station, will be used to study cold seep ecosystems, the methane-rich hydrothermal vents that teem with unique life forms and contain vast deposits of methane hydrates, also known as flammable ice. Details of the station's design were revealed this month by researcher Ian Jianping from the Chinese Academy of Sciences, South China Sea Institute of Oceanology, and his colleagues, writing in the journal Manufacturing and Upgrading Today. Pioneering features include the long-term life support system that will be needed if scientists are to build and operate a permanent monitoring network to track methane fluxes, as well as ecological shifts and tectonic activity. Construction will soon begin, wrote Ian and his colleagues, who added that the intention was for the station to work closely with unmanned submersibles, surface ships, and seabed observatories to create a 4-dimensional surveillance grid. The station will anchor a broader infrastructure web that is set to include China's massive fiber optic network on the seabed and the drilling ship Mingxiang, which aims to be the first to reach the Earth's mantle. According to a Beijing-based marine scientist who asked not to be named because of the issue's sensitivity, the South China Sea has become a frontier where biology, geopolitics, and engineering are converging. The underwater facility signaled China's shift from maritime follower to leader, said the researcher, adding that it could be a turning point in the deep-sea race. While its power source remains classified, experts have noted that analogous U.S. and Soviet-era stations, such as America's retired NR-1 and Russia's accident-plagued AS-12 Losharik, relied on nuclear reactors. The NR-1, which retired in 2008, reached depths of around 900 meters, while its Russian counterpart was capable of 2,000-meter dives, thanks to its titanium hull design, until it was left inoperative by a 2019 fire. The planned location of the Chinese facility is no accident. The South China Sea holds 70 billion tons of methane hydrates, equivalent to half of China's proven oil and gas reserves. There are also rare mineral deposits, including cobalt and nickel concentrations 3 times higher than land-based mines, along with more than 600 species that can survive in the extreme conditions, some with enzymes critical for cancer treatments. The station's deployment would also strengthen China's territorial claims, said Ian and his team, pointing out that the Losharik's 2012 Arctic seabed survey was used to support Russia's continental shelf explosion claim. According to the article, the scientists on board the facility will be able to conduct real-time experiments and adjust protocols in extreme conditions, a capability that is currently beyond artificial intelligence, AI, or robotic systems. Autonomous vehicles could fail to capture sudden methane eruptions or correctly adjust experiments that require daily pressure tweaks, the researchers wrote. The precise manipulation of drilling tools, as well as emergency decision-making capabilities and common wisdom, would need to prevail under many circumstances in the abyss, they said. Humans still matter in the AI age. It has been reported that the primary focus of the facility will be the study of cold seep ecosystems in the area. These are unique environments that have previously been found to be teeming with life, as well as home to vast deposits of methane hydrates, a resource earmarked for its potential source of energy. Speaking with reporters from the South China Morning Post, researchers from the Chinese Academy of Sciences, South China Sea Institute of Oceanology, have revealed a suite of details about the ambitious new project. These include that it will be equipped with an advanced life support system enabling scientists to operate at its depths over 1-month-long missions, host a permanent monitoring network to observe methane levels, ecological changes, and tectonic activity, and collaborate with a network of uncrewed submersibles, ships, and seabed observatories, which will work together to establish a 4-dimensional monitoring system. The project to construct the deep-sea facility, some 6,650 feet below the surface of the ocean, comes with a long list of controversies. Chief among them is the long-held territorial dispute encompassing vast regions of the South China Sea itself. The announcement of the project follows reports that Taiwan's Ministry of National Defense detected 62 Chinese military aircraft near the island territory last week. Taiwan is one of a number of countries in Southeast Asia, including Vietnam, the Philippines, Malaysia, and Brunei, that reject Beijing's claims of sovereignty and each claim parts of the South China Sea. It's an area of highly sought-after resources. In particular, the underwater region is rich in methane hydrate reserves, estimated at 70 billion tons, according to the South China Morning Post, which is roughly half of China's current oil and gas reserves. Methane hydrates have been described as ice-like solids of methane and water, holding significant potential as an untapped energy resource. Then there are the vast reserves of valuable mineral deposits, including cobalt and nickel, believed to be held in the region. A deep-sea research facility in the area would certainly solidify China's position in the South China Sea. Details of the plans were revealed to the South China Morning Post by researcher Yin Jianping from the Chinese Academy of Sciences, South China Sea Institute of Oceanology. The announcement arrives 2 years on from initial details of a U.S.-led mission to build an underwater space station of the ocean off the Caribbean island of Curacao to serve as an underwater habitat where scientists, innovators, private citizens, the public sector, and global customers can live underwater to study the ocean environment for extended periods of time. The project is currently being developed by the NOAA and Prochus Ocean Group, an oceanic exploration organization founded by Fabien Cousteau with the wider ambition of creating an international network of subsea habitats, a global smart ocean platform, to advance collaboration in marine scientific research. The global mission broke new ground at the end of last month when it signed a partnership with the Mercury Foundation to explore opportunities to launch a smart ocean tech platform in Portugal through a collaboration that will include shared scientific, environmental, and technology projects focused on climate change mitigation, pollution and ocean conservation, ocean storytelling, and sustainable marine management. Purpose and research objectives. The station will primarily focus on studying cold seep ecosystems, which are methane-rich hydrothermal vents. Research will include tracking methane fluxes, ecological shifts, and tectonic activity. It will contribute to the study of deep-sea biodiversity and unique life forms that survive extreme conditions. Findings could have applications in energy research, climate science and medicine, technological and strategic significance. The facility will support a long-term life support system to sustain scientists in deep-sea conditions. It will work with unmanned submersibles, surface ships, and seabed observatories to form a four-dimensional surveillance network. The project is part of China's broader marine infrastructure strategy, which includes a seabed fiber optic network and the deep-sea drilling ship Mingxiang. The station signals China's transition from a maritime follower to a leader in deep-sea research, geopolitical and economic importance. The South China Sea contains an estimated 70 billion tons of methane hydrates, a crucial energy resource. The region also has rare mineral deposits, including cobalt and nickel, with concentrations 3 times higher than land-based mines. More than 600 unique marine species have been discovered in this area, some possessing enzymes useful in cancer treatment research. The station could strengthen China's territorial claims, similar to Russia's use of deep-sea surveys to justify Arctic expansion.